Hello and welcome to Technology Update on Russia Today. In this edition of the program, we're going to be discussing how the biggest country in the world is making some of the smallest things on Earth. That's because we're going to be discussing the Russian contribution to Nano Technology. It may not look like it, but this is the future of medicine. These are biochips, and they allow doctors to diagnose diseases with pinpoint accuracy. We visited the Engelhardt Institute of Molecular Biology in southern Moscow to learn how extremely tiny drops of genetic material can make diagnosing tuberculosis 100 times faster than using normal methods. The robots you just saw apply dozens of droplets to glass slides in a grid pattern. Each drop contains a different DNA fragment from the tuberculosis bacteria. The genetic material is permanently fixed to the slide and is treated with a special fluorescent dye. Then the drops, only 1/1000th of a liter in volume, are exposed to blood from a patient. If tuberculosis is present, its DNA will bind to the DNA in the droplets, causing the fluorescent dye to become activated. Thus, each chip becomes an individual genetic map tailored to the patient. Once the chips are prepared, they're inserted into a computerized scanner that automatically analyzes the fluorescent patterns, telling clinicians instantly if tuberculosis is present. Biochips aren't just good for TB, they're useful for diagnosing any disease that has a genetic basis. And as scientists learn more and more from the Human Genome Project, that list is likely to grow by leaps and bounds.
So at first there was a special so-called pilot project from the Ministry of Health, Russian, where we installed our technology in 8 anti-TB centers in Novosibirsk, in Saratov, in Moscow, in St. Petersburg, and so on. Just after several months, 2, 3, 4 months, they asked to please give us more biochips because the previous technique allowed people to give the answer in, let's say, from 4 to 8 weeks, sometimes even 12 weeks. And here they have results the next day. I think that in future, this technology will just, let's say, change the whole TB technology of TB treatment.
In this clinic in suburban Moscow, Dr. Barsky's technology is already helping to save lives. To see how TB biochips work in real life, I've coughed up, quite literally, my very own contribution. This is a sample of my sputum. Now don't change the channel because this is the exciting part. We're going to give this to the technicians here for processing and then analysis using DNA microarray techniques. Tuberculosis is a big public health problem in Russia, especially in hospitals and prisons. Finding infected people and separating them from healthy ones quickly is the best way to contain the disease, something to which this technology is ideally suited. Also, the incidence of drug-resistant strains of tuberculosis is increasing, and biochips can detect its presence instantly, allowing for rapid treatment using special drugs.
Only several years ago, in order to prescribe a patient a proper chemotherapy course, we had to wait for 2 months before the results of the biology examination of the phlegm was ready. Now, thanks to the biochips technology, we can have the results of tuberculosis, microbacteria sensitivity in 2 days, and to prescribe the adequate chemotherapy schemes right after the patient is taken in.
But biochips are just the first step. Some theorists predict one day, scientists will build tiny nanorobots. They'll be small enough to travel through the bloodstream, attacking disease at the source. What do you think is the role that nanotechnology is going to play to help us live healthier existences?
As soon as we learn to apply these micro-devices of biological or technical nature to target a particular defected protein in a particular defected cell, the results are likely to be the most astonishing. Actually, we'll forget what illness means. We are in a position where nanotechnologies can take us to the level when it will be possible to prolong indefinitely the existence of a human being.
One place these new results might be born is Zelenograd, a small city near Moscow. The university here is home to this contraption called a tunneling electron microscope. It's a device of extraordinary precision that exploits the peculiar properties of quantum mechanics, allowing scientists to build new structures, a single atom at a time.
Nanotechnology comes from the most unlikely places. This is a device that uses a technique called vapor deposition to produce carbon nanotubes. These are cylinders of carbon that are only 1 atom thick, and in their raw form, they look a little something like this. Now, the source of the carbon that produces this comes from here. This is spirit. It's just pure alcohol, and in a pinch, even vodka can do the trick.
Another form of carbon that's very useful is fullerene, also called buckyballs, football-shaped molecules consisting of 60 carbon atoms. These spheres have big technological potential. Their hollow interiors can be used to deliver drugs to specific tissues, and their shape makes them strong, enough to protect against bullets in new kinds of armor. And here in St. Petersburg, they make buckyballs by the bucket load, in nanotech terms anyway. Fullerenes actually occur in everyday life. A tiny fraction of candle soot, for example, contains buckyballs. But this factory uses a high voltage arc of current between 2 graphite electrodes. The deposits that form contain high concentrations of buckyballs. The next step is to chemically isolate the mixture using solvents. What comes out is checked using spectrometry, and the result is near total purity.
Our installations work automatically non-stop 24/7. They make it possible to provide from 100 to 300 kilograms of nanocluster carbon per month.
This is the final product, 99.7% pure carbon fullerenes. This is about a kilo, which is worth about $25,000 US retail. Now I'll pour some out so you can have a look. Now you can see the clusters here. Now, each one of these particles is less than 1/100th of a millimeter in diameter.
The shape of buckyballs gives them unusual properties. High strength, low friction, and excellent conduction of heat and electricity, which makes pure fullerenes an excellent candidate for a number of applications.
Making the building blocks of nanoproducts like fullerenes is all well and good, but how do we turn them into everyday objects that can make our lives better and easier? Well, the thing about carbon is that it can be easily woven into fibers to make new types of fabrics that are unbelievably strong and light.
It costs millions of dollars to launch something into orbit, but a space elevator could let you reach the stars for a fraction of the cost. It's a future technology that consists of an enormous tether attached to the ground that reaches up past the geosynchronous orbit, some 36,000 kilometers above the surface of the Earth. Because of centrifugal forces, this cable would stay taut and rotate with the Earth. This means that small platforms could crawl up the cable and into space, just like a cable car pulling skiers up a hill. It would cost just a few dollars per kilo to get these into orbit. The cable has to be both extremely strong and very light to support its own weight, about 20 times stronger than the best steel. A cable made of interwoven carbon nanotube fibers would be perfect for the job. Some experts predict a space elevator would look like this. The cable would be anchored to the Earth on a sea-based platform that would also serve as a cargo port for sending goods into space. The cars that would travel its length would inch along, powered possibly by the sun. Research is underway to develop a kind of carbon nanotube that acts as a superconductor, so the cars themselves can use the cables as power lines. Once a space elevator is in place, it might become a low-cost gateway to space, democratizing the ascent to orbit.
If you've just joined us, we're about to pay a visit to the ancient Volga River city of Nizhny Novgorod, where we're going to find out how old discoveries are illuminating modern life.
Now, this is one way to travel over both land and water, but we have an appointment to meet something a bit more sophisticated.
Now, this has nothing to do with Nano Technology, but because we're in Nizhny Novgorod and the technology update team is used to traveling in style, we've enlisted the help of our friend Sergey, who's here to help us navigate the roads and rivers of this town. Knock, knock. Hi, Sergey. Thanks for stopping by. Now, this is quite a ride you've got here. So please tell us, what's unique about it?
Our device is peculiar for its hull being flexible. Besides, it's assembled of modules and can be disassembled and transported in 3 cubic meters to any place in the world. Such hull also adds to its shock resistance, as the pipes bend elastically but don't break. The boat can also be easily repaired. Let's have a ride, and you'll see it all for yourself.
The Strelets ACV, which stands for Ultralight Air Cushion Vehicle, is manufactured right here in Nizhny Novgorod and is sold around the world. Propelled by a lightweight rotor, it can reach speeds of more than 100 kilometers per hour and can carry 5 passengers or up to 420 kilos of cargo. Because it's nimble over land and water and itself weighs less than half a ton, it can be deployed by helicopter to remote areas. Most hovercrafts use flimsy rubber skirts on their sides to contain the levitating jet of air, but the Strelets employs sturdy pontoons to provide a very stable and comfortable ride. The passenger compartment is enclosed by a sturdy plexiglass shell, making it the ideal all-weather, all-terrain personal vehicle. The Strelets is also useful for search and rescue operations because of its lightweight and easy handling. While we were filming Sergey's Strelets, we happened to serendipitously catch the maiden voyage of this passenger hovercraft, which can transport 18 people across Russia's vast network of rivers and lakes. The Volga has a long history of innovation. New types of aquatic vehicles, especially for military use, have been developed here for more than 50 years, including this, the world's largest hovercraft. The heavy concentration of marine industry in the area has spawned a cottage industry of high-tech shipbuilding.
This is Nizhny Novgorod, formerly known as Gorky. Now, in the early part of the 20th century, this was the radio city of the former Soviet Union. The most brilliant engineers from across the country flocked here to learn the secret art of the wireless.
Chief amongst these was Oleg Losev, arguably the inventor of the first nanoscale device, the crystadine radio. This was probably the world's first semiconductor device, using a tiny crystal of silicon to amplify a signal instead of vacuum tubes. The technology behind these primitive radios is the direct ancestor of the modern computer chip.
I think in a larger scheme of things, it is Losev who's the real scientist who realized that the p-n transition played the main role in all electronic semiconductor instruments. No one in the world except Losev could have created the transistor before the war. That man was much ahead of his times, so much ahead that science forgot him during that time. Regrettably, we in Russia tend to forget our great people.
In 1929, his lab in Nizhny Novgorod closed down, so he moved to St. Petersburg, which was then called Leningrad. And he began working here at the Central Radio Laboratory, where he refined his work on semiconductor theory, which led to the very first LEDs.
Losev worked on special combinations of semiconductor materials to make better radios, but he noticed that his device produced a strange glow. He was the first to realize that this light could one day be used to illuminate the world. It was the first light-emitting diode, or LED.
But in 1934, the radio laboratory was closed down, and Losev couldn't get a job anywhere else because his boss refused to give him a recommendation, probably because of a political disagreement. So for several years, this immensely talented young scientist was out of work, until somebody here at the Medical Institute, which is behind me, took pity on him and finally gave him a job.
Here, Losev continued to work on a number of projects, even devising a prototype for a machine that could restart the heart using electricity, the forebear of the modern defibrillator. But once again, his work was disrupted, this time by the onset of war. In 1941, the Nazis blockaded Leningrad, cutting off the flow of nearly all supplies. At the height of the siege, residents starved to death in their thousands.
Oleg Losev died unrecognized for his genius of hunger in 1942 during the siege of Leningrad. Nobody knows exactly where his body is buried, but it's quite likely that it's here, in a mass grave on the outskirts of St. Petersburg that contains the remains of the more than 1 million victims of the siege.
We are at the threshold of a revolution in lighting, and this lighting will be on the basis of light-emitting diodes. I mean torches, car lights, road lighting, traffic lights, etc. This is already a fact that everyone can see, but regrettably all these phenomena are not often associated with the name of Oleg Losev.
In Southampton, in southern England, a Russian scientist who's a leading researcher in optical physics credits Losev with helping to bring the 20th century out of the darkness.
His legacy is just beyond my work. It cuts into many aspects of modern physics. The progress of civilization will be relevant to the progress of information transfer. The more information you can handle, the more information you can exchange will determine the wealth of the nations. And this will be part of this paradigm. So handling information with light will be the most important thing of the future.
In Siberia, in a small town outside the city of Novosibirsk, a Russian company is using nanotechnology to transform ordinary carbon into something a lot more precious.
Researchers here are hoping to put new sparkle into an old classic by changing the color of diamonds and building new ones from scratch.
So, people have been collecting normal diamonds for thousands of years, and they're highly prized and valued for their beauty. Why do you want to mess around with things? Why do you want to change their color?
The colored natural diamonds take only an insignificant share of the market. They are quite seldom on sale. In fact, these diamonds are not available for the medium-class consumers. That is why we started to produce such crystals. We apply physico-chemical processing to the crystals with low-color characteristics to artificially acquire unique colors. On the one hand, these colors are staying permanent. They don't change. And on the other hand, they are much more democratic. I mean, the middle-class people can afford them.
Welcome to the kitchen, where synthetic diamonds are cooked up, so to speak. Now, we on Technology Update are going to give you the exclusive recipe. To start off with, you're going to need a seed crystal. Now, these are tiny, tiny diamonds, only a fraction of a millimeter across. So you simply add one of these to this high-pressure crucible, then sprinkle in some graphite, which acts as the building material for your diamond, then seal up the apparatus, cook at 1500 degrees Celsius at 5 gigapascals of pressure for about a week.
Unlike the other rooms, here we burn natural diamonds. In this way, we can control the pressure inside the high-pressure apparatus, and in that way, we control the temperature. These parameters are much higher than when diamonds grow. The temperature rises almost to 2000 degrees centigrade, while the pressure is 7 gigapascal. So we're not talking about weeks and days, but only for several minutes. The crystal's burning lasts up to 20 minutes.
In this facility, behind concrete walls a foot thick, a particle accelerator produces powerful beams of electrons. By placing a diamond in the beam's path, the internal structure of the carbon lattice is altered, changing the color. A number of different shades can be made to order, from yellow to bright green. But the specialty of the house? A brilliant crimson called Imperial Red.
Once the diamond has been synthesized, it needs to be polished and cut. And the final step is to check the quality by using this apparatus to shine a laser through it. Now, each one of those spots represents a reflection off one of the facets. And the sharper the reflection, the nicer the cut. We've heard from the professionals about the merits of synthetic diamonds, but we took to the streets to hear from the real experts, the ladies. Because, and I hardly need to say it, diamonds are a girl's best friend. So here we have the real McCoy, and here's a fancy fake. Will they be able to tell the difference? And more importantly, in terms of matters of the heart, does it even matter?
One diamond is cultured and the other one is genuine indeed. Is it correct?
I think this one.
The green.
The green.
This is more sparkling, so it's true.
I guess both of them are artificial.
In my view, true diamonds mean classics, but cultivated ones match youngsters.
By their look, there is no difference, no in clarity, no in faceting. They're regular.
It proves to be worse without them.
Genuine diamonds are just better.
That's all for this teeny tiny edition of the show. Join us again next time when we'll be back to our regular size. As always, send us your questions or comments to techupdate@rttv.ru. I'm Paul Tadich, and thanks for watching Technology Update.